these shifts in pH from drinking things like lemonade. It could potentially kill you if you didn't have these buffers already in the bloodstream. So let me erase a couple things here because this is super important. One of the major buffers that we have in our bloodstream, and it's produced mainly in our kidneys, is a buffer we already talked about a little bit. This is the bicarbonate ion. And it's floating around in our bloodstream at all times, as long as we're a healthy person. So I'm going to drink those 6, 7, 8 glasses of lemonade, and I'm going to have a ton of hydrogen ions entering into my bloodstream. But my bicarbonate ion is there and waiting. And watch, here's all my hydrogen ions from my lemonade mixing with my bicarbonate ions, and I make this chemical here, okay? So I have my hydrogen ion. And my bicarbonate ion, and I make, a chemical called carbonic acid. Now, carbonic acid is what we would call a weak acid. Now, what that basically means is, as soon as it's formed, it breaks apart. So if you get it 1 second, the next second, it's gone. And what it's going to break apart into is water and carbon dioxide. In order for my pH to drop after I drink those lemonade, I have to have my hydrogen ions floating around freely, not bonded to anything else, to drop the pH. So if I get these hydrogen ions to bond immediately to bicarb, my pH won't change. And I can drink tons of lemonade and I don't have any pH change. Now, I might have to pee and burp afterwards, but you know, we're okay. There's no pH change. Okay, but what if I have a patient who is in renal failure and they're on dialysis? Could drinking 7 or 8 glasses of lemonade kill them? Yes, it could. Because we make most of our bicarbonate in the kidneys. And if their kidneys are not functioning and they're not making enough bicarbonate, one of the things you do tell your renal patients is, I'm sorry, you can't eat or drink really super acidic substances. Now there's other things they can eat and drink too, but acidic substances are definitely one of them. Any questions? Okay. Now, one last concept I want to go through, and then we'll take a break before lab. It has to do with this equation right here. So this equation is an interesting equation. The way I've written it, we're going from hydrogen ions binding to bicarb, or making CO2 and water. But officially, this equation actually does this. It has the ability to go forward or backward, you might say. So let's say I gave you this equation on an exam. And I said to you, tell me, which way is this equation going? To your right or to your left?
Either or.
Are you sure? It depends. It depends on what? Your pH. Okay, maybe. What does it depend on? Because it can't go both ways at the same time. It can only go one way or the other.
Concentration.
Of what? Of either? Of either of each?
Depends whether or not you make a basic situation or a acidic situation.
Maybe. All right, let's look at this. All right, let's go way back into chemistry. All right, A plus B Yep. Mhm. So these are your reactants, and they create your product. Yes? Okay, simple. So let's say I have a beaker, and I'm actually going to make AB. So the first thing I'm going to do is I'm going to pour into my beaker A, and I'm also going to pour into my beaker B. Yes? And eventually, after I stir, what will I have? AB. Okay, but in the beginning of this reaction, what did I have in the highest concentration? A and B. At the end of the reaction, what did I have in the highest concentration? AB. Okay, now this is important. We always go from reactants to products, yes? Okay, so reactants are always in the highest concentration in the beginning of the reaction. Products are in the highest concentration at the end of the reaction. So what if I say to you, let's go back to our lemonade drinking person. I have a person who just drank a whole bunch of lemonade. Which way does my equation go? To your right or to your left? To your right. How did you know? Perfect. We started out with more hydrogen ions in the beginning of the reaction, so this made hydrogen ion the reactant. Yes? All right. So what if I say to you, I have a person who is holding her breath. Which way is my reaction going? To the right or to the left? She's holding her breath, so what does she have the most of? CO2. So if CO2 is in the highest concentration in the beginning, this is a reactant, so the equation has to go in this direction, yes?
Yes.
Yeah. All right, so if we have a patient who holds their breath, okay, I'm going to make it a little harder. If we have a patient who holds their breath, what happens to their pH? Does it go up or down? Watch. This is the reactant. I am making more product. The more hydrogen ions I have, is my pH going to go up or down?
Down.
Down. See why you got to memorize that? So if I have somebody who is holding their breath for too long, their pH will actually go down. You know, when I was in medical school at Loma Linda, we had a teacher who was teaching us physiology, and when he got to this part, he said, okay, so now can I have a volunteer to come up and hold their breath? You know some dummy did it? He came up, he volunteered, held his breath, and passed out. It's like, why would you do that? Okay, just dumb, okay? I don't understand that. All right, anyway. I didn't even get any extra credit, he just did it. Okay, that's just the dumbest part. Okay, so now, all right, now let me ask you this one. Keep in mind, reactants are in the highest concentration in the beginning, which also means products are in the lowest concentration in the beginning, or not at all, okay? So what if I tell you now I have a patient who is hyperventilating? Which way does the reaction go? To your right or to your left? Which way does it go? Why do you pick that it goes to the right? Just a good way.
It's opposite way?
Why?
Because by way you explained that you're holding, it's to the left because you're holding the carbon dioxide.
Is she holding it in? Because watch,
No,
hyperventilating.
You're releasing,
Okay, I'm releasing. So that means CO2 levels are going to be low. If they're low, does that make them a reactant or a product? It's a product. So then the equation goes towards the product. Okay, let's try another one. Don't worry, we'll do this a lot because we're going to use this equation more. All right, so let's say that I tell you I have a patient who is vomiting, lots and lots of vomiting. And when a patient vomits, and I'll explain how this happens later, they get a lot of bicarbonate in their bloodstream. Which way does the equation go, to the right or to the left? Okay, keep in mind, reactants are in the highest concentration in the beginning, products are in the lowest. So bicarbonate in the bloodstream is going up. Does that make it a reactant or a product? Reactant. Which way does the equation go? This way, to the right. Okay, so you have to keep in mind, reactants highest, products lowest. And we always go reactants to product.